All right, here we go. This is an intro to LT6 explanations with energy. So we're going to read through the problem once, and then we'll annotate it, and we'll work through it together. So, two skaters of equal mass start from rest at the top of the hill. They roll down the frictionless surface to the ground on opposite sides of the hill. So one's going this way, and one's going this way. The skater on the right travels a greater distance along the hill surface than the skater on the left. Ignore air resistance. The question to answer is, how will the velocities of the two skaters compare at the bottom of the hill? Okay, let's go through and pull out some pertinent information. Two skaters of equal mass start from rest at the top of the same hill. Super important there. So what does that mean? Let's jot down our equations, because if you don't have these in your head, it's not going to work out well. So K equals 1 half mv squared. UG equals mgh. And work equals force times distance. Okay, so equal mass. That is nowhere down here. Mass is not in the LL diagram. Start from rest. Velocity is not in the LL diagram. Top of the same hill, so same height. Height is not in the LL diagram. None of those things are in the LL diagram. That's why these equations are so important. Put the information together. Equal mass from rest. So masses are equal, but from rest means zero velocity. So 0 times anything is 0. So they have no kinetic energy. So we're going to, first things first, starting off, they have 0 kinetic energy. So we'll just put 0 there. Then, but then also equal mass and top of the same hill, we can talk about their UG. So same mass. Gravitational field strength is the same, they're both on Earth. Same height, they're going to have the same UG. So we're going to have the same UG over here. Now, how much UG you want to put there, I don't care. I'm going to put 4 because, that's just a nice number. Okay, so there's 4. We can shade it in so it looks all nice. And we're already starting to build our equation, 0 plus 4. And they have the same UG because they have the same mass and the same height starting off. So their initials look to be exactly the same, 0 plus 4. Now it's going to be 0 plus 4 equals, or plus blank equals blank over here. So we're saying they're starting with 4 units of energy, both of them. Now, we may take away some energy, or we may add some energy, and then that's going to tell us our final. So let's just keep reading. They roll down the frictionless surface. All the way to the ground on opposite sides of the hill. So they're going to end up, let's come back to the frictionless part. They roll down to the ground, so that means their height is 0 at the end. So their UG is 0. So let's fill in UG of 0 here. That's going to be 0. And UG is 0 here. That's going to be 0. Now it says the frictionless surface. So the skater on the right travels a longer distance than the skater on the left. However, that really doesn't matter. Even if this distance is 1 billion, if the force here is 0, 0 times 1 billion is still 0. So there's no work done. There's no energy transferred in or out. So we can just put a 0 here for our equation. So now we're almost done. We have 0 plus 4 plus 0 equals blank plus 0. Well, we only got one unknown there. It's got to be 4. So let's put a 4 here. And this tells us that the first skater has 4 units of kinetic energy. Now the equation on the right, 0 plus 4 plus 0 equals 4. So this skater also has 4 units of kinetic energy. And at this point, we're done with the LOL. There it is. So the evidence part. So we're going to have evidence, and then there's a claim, and there's a concluding statement, okay? Whoops. So it says, in order to answer the question above, you need to look at, this gets to this idea that I was getting at before. Will the velocities of the two skaters, how will they compare? Velocity is not on this LOL diagram. Just from the LOL diagram, you can't tell. You can't answer this with just the LOL diagram, okay? So what are we going to have to look at? Where's velocity hidden in the LOL diagram? It's hidden in the kinetic energy. So circle K, and the kinetic energy, well, if I want the velocities at the bottom, I want the kinetic energy at the end. So what I'm looking for, I got to look at those. All right, now we're going to explain how you determine. You can type this. Let's see. Let me see if I can type this, and it'll kind of covers the screen and is a little obnoxious. Oh, there we go. Maybe. Okay, so what we're going to do is, we're going to start at the beginning. And so we're going to say it starts at rest. So there's no kinetic. I'm explaining how I got all my parts of the LOL. So no kinetic initially. Also, what else? How did I get that other part? How did I know the UGs were the same for both? That was because it was the same mass and same height. Same UG. Whoops, same zig. Same UG initially. Feel free to pause this video and type and you can follow along with me and then hit play again. One thing I like to do, it takes a little bit of extra time though, is like underline or bold. Oh, underline doesn't work. Well, oh well. Like I would bold like rest and no kinetic energy and mass, same height, same UG, those keywords. Okay, so how did I do the middle? Well, I said that there was no friction. So no energy removed. The distance does not matter in this case because 0 times anything is 0. So one went for a further distance, but we weren't taking energy out. There wasn't a force working against her. So it doesn't matter in terms of amount of energy because no energy came out. Okay, so now I've talked about my initial L. I've talked about the O. Now at the end, how did I figure out the end? Well, I know that there's no UG at the end because there's no height. Okay, so I can say, let's see. Oh, I'm going to change the order just slightly here. So I'm going to kind of zoom out into a big picture. You'll see why in a second. So I'm going to say same initial energy because they both started with 4, and no energy transferred. That's no work. So this is me applying conservation of energy here. Okay. Same initial energy and no energy transferred means same amount of final energy. All right, so now I've said, okay, I get the same amount of final energy. How do I figure out where it goes? So at the end, no height, so no UG. Oops, so no UG. So all energy is K. Come on. Is K at the end. So same final K. So I'm saying at the end, there's no height, so there's no UG. So it's going to be all kinetic energy at the end, so same final K. So in the third kind of bullet point, third idea, I said they have the same amount of they have the same total amount of energy at the end. And then the last one I said, well, all that energy has to be K, so it has to be the same amount of energy, the same amount of K. But I'm not done yet. So pause the video there if you want. You need to catch up, think about it, write down questions. I have to answer the question, how will the velocities of the two skaters compare? Well, I haven't gotten there. I haven't said anything about final velocity. So I'm going to go back and I'm going to look here. I have to look at the K at the end. So K is 1/2 mv squared. So under the concluding statement here, right, K equals 1/2 mv squared. Now, to get the final velocity, I need to know about their masses and about their kinetic energies. So they have the same mass, which was a given. And can you turn that down, sweetie? And same K final. So looking at the equation, same mass, same K final, so same V final. Notice here I wrote my concluding statement before I circled the claim. Totally okay to do that. You may not be able to look at this and know the claim from the get-go. So now I look at that, I can say, hey, they have the same speed, okay? And I've concluded that, all right? So that is number 1. There you go.